Welcome back. In this video, we will be looking at some examples of unit conversion. Let's look at an example calculating average speed. In here, we are told that you drive 10 kilometers from your university to home in 20 minutes. We are asked to calculate the average speed in two units, kilometers per hour and meters per second. The physics idea here is average speed. So average speed is equals to distance traveled, let's say delta x, divided by the time of travel, let's say delta t. Now the concept is simple, but the units require attention because delta x is given in kilometers and delta t is given in minutes. So if we want our final answer in kilometers per hour, then this part is okay, but here we have to convert the time from minutes to hours. So let's see how we can solve this problem in the next slide. So when we solve a problem, the first step is writing down the known values. So we know the distance is 10 kilometers and the time is 20 minutes. Now let's first find the speed in kilometers per hour. So we already know the distance in kilometers and we have to find time in hours. So the conversion factor related to this is 60 minutes is equals to 1 hour. From here we can create a fraction 60 minutes divided by 1 hour equals 1, and also 1 hour divided by 60 minutes is equals 1. So depends on our conversion, we pick the fraction we want. In this case we want to convert 20 minutes into hours. So we have to multiply 20 minutes by 1 hour divided by 60 minutes. So we get this minute cancels out and this gives us 20 minutes times 1 hour divided by 60. So the minutes already cancelled out, and this is 20 times 1, this is 20 times 3. So we get 1/3 of an hour, which is equal to 0.333 hours. Now we found our time in hours and we know our distance in kilometers. So the average speed we average is delta x over delta t, which is 10 kilometers divided by 0.333 hours. and this is giving us 30 kilometers per hour. Now let's look at part B. We already found average velocity is 30 kilometers per hour. Now we need this to convert into meters per second. On it. Now 1 kilometer is equals to 1000 meters. So from here we get the fraction 1000 meter divided by 1 kilometer is equals 1. So we need this fraction to multiply here in order to cancel out kilometers and give us meters. And we also need to convert the time. So 1 hour is equals to 60 minutes, and then 1 minute is equals to 60 seconds. Now using these two, we have 1 hour is equals to 60 minutes multiplied with 60 second divided by 1 minute, and here minutes cancels out, giving us 60 times 60 seconds, which is 3600 seconds. Now 1 hour equals 3600 seconds. So from here we get our second fraction that we need, which is 1 hour divided by 3, 3600 seconds equals 1. Now our conversion becomes V average equals to 30 kilometers per hour multiplied with 1000 meters per 1 kilometer multiplied with 1 hour divided by 3600 seconds. Now from here you can see kilometer cancels out, and then this hour also cancels out, leaving us meters per second. So here we have 30 times 1000 meter divided by 3600 seconds, and this is equals to 8.33 meters per second. Now to solve this problem, you can convert the 10 kilometers into meters and convert 20 minutes into seconds, and then use the average velocity equation again as well. So there are several different ways of solving a problem and I just wanted to show you how to deal with different units. So I kind of used this longer path, but you can do the other way as well. In this example, the density of iron is given as 7.87 grams per cubic centimeter. Now we have to express this in SI units. So the density is equals to mass divided by the volume. So in this case, mass is measured from kilograms, volume is measured from cubic meters in SI units. So we need to convert uh, this 7.87 grams per cubic centimeter into uh, kilograms per cubic meter. So the conversion factor related to this is 1 gram is equals to 10 to the power minus 3 kilograms, and 1 centimeter is equals to 10 to the power minus 2 meters. Now, what we want is cubic centimeter, right? So 1 centimeter cube is equals to 10 to the power minus 2 meter cube. We get cubic centimeter. 1 cubic centimeter is equals to 10 to the power minus 6 cubic meter. All right. So the conversion fractions we have here is 1 gram divided by 10 to the power minus 3 kilogram equals 1. And we also have 1 cubic centimeter divided by 10 to the power minus 6 cubic meter equals 1. And then we can use this in our conversion. So the density of iron can be written as 7.87 grams per cubic centimeter multiplied with 10 to the power minus 3 kilograms divided by 1 gram. So if you notice here, I used the fraction that would cancels out the grams from what we have, right? So instead of using 1 gram over 10 to the power minus 3 kilogram, I used here 10 to the power minus 3 kilogram divided by 1 gram. So I can cancel out this grams with it. And then I also multiply this with 1 cubic centimeter divided by 10 to the power minus 6 cubic meter. So my cubic centimeter cancels out, leaving me with 7.87 times 10 to the power minus 3 kilograms divided by 10 to the power minus 6 cubic meter. So 10 to the power minus 3 divided by 10 to the power minus 6 gives me 10 to the power 3. So this is 7.87 times 10 to the power 3 kilograms per cubic meter. And that is equals to 7,870 kilograms per cubic meter.